Hello, this is Mrs. Brown, and today we're going to talk about the probability of a compound event. So we'll start with some vocabulary. A compound event is two or more simple events. So it's this happening and this happening. So if I flip a coin twice, I flipped it once as one event, I flipped it a second time, the second event, and kind of seeing what happens, the possibility, what's the probability I'm going to get both tails or those kinds of things. So looking at the probability of like two or more things happening, okay? So we've beyond just the one thing happening. Okay. A sample space, is it just a way of saying a set of all the possible things that could happen? And then a tree diagram is a way that we can actually represent the sample space and kind of help us to see what's going on. So in this simple example, if I flip a coin twice, the first flip, I can get heads or tails. And if I get heads the first time, on the second flip, I can still get heads or tails. Or if I get tails the first time, I can still get heads or tails. So all the possibilities are getting heads twice, a heads and then tails, a tails and then heads, or a tails and then tails. So if I wanted to, for instance, figure out what's the probability of getting tails twice, it's 1 out of the 4 possible outcomes, so it has a 1 out of 4 chance. Okay. So let's look at another example. Okay, so on vacation, Rachel brought 3 different pairs of shorts, black, navy, and tan, 3 different shirts, white, pink, and green, and 2 pairs of shoes, sandals and sneakers. How many different outfits can she make? So I could represent this in a tree diagram, and I did kind of start that whole process here because it would take a while to write out. But if you look, I could have black shorts with a white shirt and sandals, or black shorts with a white shirt and sneakers. The first row represents the shorts, and then there are 3 possibilities for shirts. So you notice that there's 3 branches off each of the types of shorts. And so I have white, pink, and green, white, pink, and green, white, pink, and green. So if I get navy shorts and white, or tan shorts and white, and etc. And then depending on whatever short and shirt I get, I have 2 possibilities for shoes. So I could have, the black shorts with a white top with the sandals, or the black shorts with a white top and the sneakers, and so on. And so this is a way of kind of showing all of those possibilities. And I can write that out. You can see the first letter represents the shorts, the second letter represents the shirt, and then the third one represents the shoes. And so these are all the possibilities of all the different things. And that's like following these branches. And so I didn't quite finish this one. I got tan shorts, white shirt, sandals, tan short, white shirt, sneakers. So if I look, my other branch, tan short, pink shirt, sandals. And then I could also have tan shorts, pink top, and sneakers. And then finally with the green, so I have a tan shorts, green top, and sandals, and a tan shorts, green top, and sneakers. Okay, and so this is all the possible things all the possible outfits. Well, how many? I've got 1, 2, 3, 4, 5, 6. I've got 3 columns, so that's 18. There's 18 possible outfits based on what we have here. So let's say she randomly picks one of each. She picks 1 short, 1 shirt, and 1 pair of shoes. So what's the probability that it's going to come out to be tan shorts? Well, there's 18 total, so that's my denominator. And if I look at tan, there's no tan here, there's no tan here. There's 1, 2, 3, 4, 5, 6 possibilities that have tan, which simplifies to 1/3. So she's a 1/3 chance of getting tan shorts. The probability of not sneakers. So if I look, for instance, the probability of not sneakers, every other one, so 1, 2, 3, I'm sorry, not sneakers, sandals. So 1, 2, 3, 4, 5, 6, 7, 8, 9. I can figure that out. That would be 9 out of 18. And that would give me 1/2. The probability of a white or green shirt, again, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And so that would be 12 out of 18. Those are all pretty simple ones. Let's say that we wanted to instead figure out what the probability of, say, black shorts and sandals. So we wanted black shorts and sandals. Well, if I look, black shorts are only in this column, and I want sandals. So none of these count because I have to have black shorts. So sandals 1, 2, 3. So only 3 out of the 18, or 1 out of 6, gives me both black shorts and sandals. Okay. And so that's kind of how we use this information. We can kind of organize it in a way that makes it really easy to kind of answer those types of questions. Okay, let's look at another example. And this time we're going to create the tree diagram. So let's say that there are new shoes. They come in red, blue, orange, and yellow. Woo! And you can have white or black laces. So if I were going to create a tree diagram, you can either create it down or across, whatever you're more comfortable with. Since I did the other one down, let's do this one across. I've got red, blue, orange, or yellow shoes. Okay, and then I have a choice of white or black. And I'll just put, we know that's the laces. Okay, white or black laces, and white and black laces. Okay, so this shows me all the possibilities. What are the possibilities that I have? Well, I could have red with white laces, red with black laces, blue with white laces, blue with black laces, orange with white laces, and orange with black, yellow with white laces, and yellow with black laces. Okay, so there are 8 different possibilities for this. And let's say I wanted, the probability of getting orange shoes with black laces. Okay, and so what I would do is I would look at my list. Okay, orange shoes, these are only orange shoes and only one possibility of black laces, so that probability would be 1 out of 8 because I've got 8 possibilities and only one has orange and black. Another way that you can organize this is using a table. When you have 2 possibilities, this works well for 2 possibilities. So I have the red, I have the blue, the orange, and the yellow shoes. And then you could have white or black laces. Again, what am I going to do? I'm going to go here and I am going to just pair them up. I can have red with white or red with black. See, that's the same kind of thing that we did here. I can have blue with white or blue with black. Orange with white or orange with black. And I'm just kind of taking those and pairing them up. And that's another way to organize data. Some people are much more comfortable using a table than they are for a tree diagram. When you have 2 possibilities, a table works just as well. Okay. So I would like you to pick kind of what you're more comfortable with in terms of writing that out. All right, let's look at one more example. Let's say you rolled 2 number cubes, so those are 1 through 6, and you want to multiply the numbers and then answer some questions about it. So all the different possible outcomes. This is a good one for a table. You've got 6 this way and 6 this way. Could you make a tree diagram? Absolutely. But this kind of question, to me, I find it easier to look at a table for this. And again, I only have 2 possibilities, so it's real easy to do. So if I look, I've got 6 in each row and 6 rows, so that's 36 different possibilities. Okay, and so my probability, the denominator is going to be 36. How many of those are 18? Well, if I look, I've got an 18 here and an 18 here, so only 2 of them. So 1 out of 18, if I simplify that, my probability of getting an 18 as a product is going to be 1 out of 18. Okay, let's say I needed to do multiples of 5. Okay, well, if I'm doing multiples of 5, okay, then I would do things like circle the multiples of 5, and then I could figure that out. Okay. And then I just count. And that's all the multiples of 5. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Make sure you don't count 25 twice. So that's 11 out of 36. And you can't simplify that. So that is the final probability. Okay. I hope this helps and have a fabulous day.